Hey guys, what's up, people? Long time, long time. I know it's been far too long for CBSE ninth. It's been a very long wait. I understand it's actually been more than a month since we have last taken a session for CBSE ninth students. I'm really sorry about that case. We were very caught up with the Sprint X series for ICSE 10. That was the problem. Anyways, I'm back. We are back with a bang. Today we'll be doing one short series of motion. So that means that we'll be doing the entire chapter, some important problems that can be asked from this chapter, and everything that is important from this particular chapter. We'll be going through all of that. So get ready for that. Make sure that you stay till the end. Make sure that you check out the homework questions. Make sure that you solve all the questions that I'm going to ask you today. And more importantly, try to take down the notes as well, because everything that I'm going to say today is super duper important. Everything that can be possibly asked from this chapter, we're going to cover it up. All right, so it's going to be one full chapter in just maybe 45 minutes to 1 hour. That is the intention. So without wasting any time, people, let's begin. My name is Anoop and a very warm welcome to Vedantu. I really hope that all of you guys are doing good and your preparations are going amazing. I know that a lot of you guys your finals have already started, but nonetheless guys, it's still going to help you out in the future at least. So pay attention and stay until the end, and do not forget to subscribe to the channel. Do not forget to hit the bell icon and be notified of all the sessions. And also like the video, people. What is this? Anyways, so people, this is the code for today. No matter where you are right now, whether you have started your preparations or not, whether right now you're you have a lot of problems in life, no matter what the situation is, all I can say is this: right now the only thing that you can control is your action in the present. A lot of things would have happened in the past, but there's no point in thinking about it because it's already done. You really can't go back in time. There's no time, and I don't, what is it? There's no time machine like in Back to the Future 1, 2, and 3 and all. You can't go back and change what has already happened. But what you have right now is the present. So grab hold of that present, utilize it so that your future can be better. All right. So don't focus on all these naysayers, all things that has happened in the past. Don't worry about what and all can go wrong in the future, because 1,000 things can go wrong in the future. But if you take the right step today, that will not happen, right? So this is all I have to say. All we have is now, the present. So utilize that. All right, people. So with that said, let's begin today's session. So these are the topics that we have in store for you people. So we'll start with what is distance, displacement, and speed and velocity. One of the basic concepts of motion. You already know about it, but we'll go through it nonetheless for all those who are still confused about it. What is acceleration? We'll also solve some numericals based on it. Distance time graph and velocity time graph, and the graphical derivation of equations of motion, which by far is one of the most important derivation that you possibly have from this chapter. So with that said, people, let us begin. So this is the mind map of this entire chapter. Everything that is there, that is needed, everything that you're supposed to study from this chapter in one shot. So what I want you guys to do right now is pause the video, take a screenshot of this, keep it with you until your finals. Trust me, it'll definitely be helpful. So these are the things that we'll be looking into. What is uniform motion? What is non-uniform motion? Uniform motion is when a body is covering equal distance in equal interval of time, whereas non-uniform motion is when a body is covering unequal distance in unequal interval of time. And when you draw a graph of uniform motion, basically the graph would be a linear graph. Again, it's a distance time graph, so it's going to be a linear graph. If it's a velocity time graph, then the graph is going to be parallel to the x-axis if it's uniform motion. On the other hand, if we talk about non-uniform motion, then it's going to be a curve. That is what non-uniform motion is. So you can see this. This is distance time graph. In velocity time graph, it's going to be parallel to the x-axis. Then we also have rate of motion, in which we understood about what is speed, what is velocity, what is acceleration. So speed is nothing but total distance covered by total time taken, and 1 kilometer per hour. If you want to convert to meter per second, that's 5 by 18 meter per second. And if you want to convert from meter per second to kilometer per hour, that's 18 by 5. Then you have 1 mile per hour. So 1 mile is equal equal to 1.6 kilometers. So 1 mile per hour is equal to 1.6 kilometers per hour. So what is velocity? Is nothing but displacement by time, or rate of change of speed is what is called as velocity, and acceleration is nothing but rate of change of velocity, which is nothing but velocity, a change in velocity by time taken. The formula is what? A is equal to v minus u by t, where v is the final velocity, u is the initial velocity, and t is the time taken. Then you have three equations of motion, the graphical derivations of that is v is equal to u plus at is equal to ut plus half at square, and v square is equal to half u square plus 2as. So all of these will be deriving it later, so don't worry about that. We also talked about change in, this is the very first topic, change in position, that is what is distance and displacement. Distance is nothing but the paths taken by the body, displacement is nothing but the final minus initial position, or the shortest distance between any 2 points is what is called as displacement. Then we have the velocity time graph and the displacement time graph. So in a velocity time graph, if you find out the slope, that will give you the acceleration, and the area under the curve will give you the displacement. In a distance time graph, the slope will give you the speed, and the area under the curve will give you what is the distance. You don't generally find the area under the curve in that case. Sorry, my bad. Then we also have uniform motion. The uniform circular motion, when a body is moving with constant speed, in a circular path, that is what is called as uniform circular motion. And the formula to find the speed, v is nothing but the speed. Speed is equal to 2 pi r by t, where 2 pi r is nothing but the circumference of the circle, t is nothing but the time taken. S is the displacement, u is the initial velocity, v is the final velocity, a is the acceleration, t is the time taken. Right. Then we also have, that's pretty much it. So change in position we've already seen. So let's begin, people. Well, that was the entire overview of the chapter. Now let's get into each and every topic one after another. Let's shoot them down. Let's begin, people. The first thing we're going to talk about is what is motion. The change in the position of a body with respect to time, that is what is called as motion. So with respect to time, that is 5 minutes from now, if my position sitting on this chair, if I move around, that is what is called as motion. So the change in position of a body with respect to time is what is called as motion. Now, there are two things that you have to understand when you talk about a body which is said to be in motion. One is distance and the other is displacement. So let's say that you're walking all the way from A to B, all right, and then again you're coming back all the way to C. Alright, so you're going from A to B and then you're coming back to C. So you can see that GIF, right? You can see the person walking and then coming back to C. Now, distance is the path covered by the body, or the measurement of the total length of the path, or the path covered. That is what is called as distance. So here, what will be the distance traveled? Distance will be 0. So 0 to 100 he goes first, then from again back to 50. So in total, he has traveled, or he or she has traveled a distance of 150 meters. Let's take it as meters. So 150 meters is the distance traveled, because that is the total path taken. He goes all the way from A to B, that is 100 meters. Then from B to C, that's another 50 meters. So 150 meters is the distance traveled. But what is displacement? Displacement is nothing but the final position of the body minus the initial position of the body. Now look at that. The final position of the body is at C. Initial position is at A. So what is the final position? Final position is 50 minus 0. So the displacement becomes 50 meters. So what you have to understand is this, guys. Displacement is path independent. It does not depend on the path taken by the body. It only depends on where is the final position of the body and what is the initial position of the body. Or in other words, the shortest distance between 2 points is what is called as displacement. So this is completely path independent. So you have another example over here. So you see this, you go all the way from here, you take a very long path and you reach this point. Now this is the distance traveled. That is the distance traveled. The path taken by the body is the distance traveled. But what is displacement? This is the final position. This is the initial position. So final minus initial position would give you what is the displacement, which is generally the shortest distance between any two given points. So that is what is displacement. So once again, guys, remember this, that no matter what path you take. So you see this, guys. So that you have 3 or 4 paths to go from A to B. All right. But then you see this. In all the cases, the distance might be different, but displacement is the same, because finally you're reaching the same point every single time. So it does not matter what path you take, you're ultimately going to reach B itself. So final position minus initial position is going to be the same for distance 2, distance 1, distance 3. It does not matter. See, for example, guys, let's say that this is 7 kilometer, this is 10 kilometer, and this is 5 kilometer. Even though the distance in these three paths are different, displacement will be the same for all the three cases, right? That is one thing you have to understand, guys, because from this you have to understand that distance is a scalar quantity. All right, it does not, there's no direction involved, but displacement on the other hand is a vector quantity. So you have positive as well as negative displacement as well. So if this, let's say that this is the starting point, if you're going towards the right hand side or towards the east, then it's taken as positive. If you're going towards the left hand side or towards the west, that is behind the initial position, that is taken as negative displacement. So that is one more thing you have to remember. And because of this thing, this is the reason why, guys, displacement is a vector quantity, not a scalar quantity, because you consider the direction also. See, in distance, you don't consider the direction. You don't care what direction you go, left, right, north, south, in between, north, east, does not matter. But in the case of displacement, you also consider the direction as well. So you have negative displacement and positive displacement as well. Whereas distance on the other hand is a scalar quantity which does not depend on the direction at all. Displacement on the other hand depends on both magnitude as well as the direction, and that's why it's a scalar quantity, right? Sorry, vector quantity. So guys, let's solve some question now. One quiz question. So I'm going to ask you this question. I want you to do it, be honest to yourself. I want you to do this question by yourself with your own abilities. I don't want you guys to Google the answers. I don't want you to cheat. Don't ask your brothers, don't ask your parents. I want you to solve it because you're the one watching the video. You're the one who's going to write your exams. So be honest to yourself. Try and solve this question. Alright, the question is this: an object moves along the grid through A, B, C, D, E and F as shown in the figure. The side of the square, each tile measures 0.5 kilometer. That means each of these is 0.5 kilometer. This is also 0.5. This is also 0.5. So all of these, the distance, each cube is basically 0.5 kilometer. Calculate what is the distance covered by the moving object and also find the magnitude of the displacement of the object. The options are 6.5 kilometer and 6.5 kilometer, both distance and displacement, 6.5 and 2.5, 60 and 5, 70 and 0. Go ahead and try and solve this question, people. So let me also do it for you guys. So first thing, find out the distance. What is the distance traveled? He goes all the way from here to here, then to here, then here, then here, and then here. So what is the distance traveled? This is 0.5, 0.5, that is 1, 0.5 plus 0.1 again 2, 3, 4, 5, 6, 6.5 kilometer is the distance traveled. So 6.5 kilometers is the distance traveled because that is the path taken. But displacement on the other hand is the shortest distance between 2 points. So that means the shortest distance between A and F is what? This is the shortest distance between A and F, a straight line that is joining A and F. So how do you find out what is the displacement now? So how do you find out this distance? What I'm going to do is I am going to assume this to be a right angled triangle. Now that you know that it's a right angled triangle, which formula do you think you should use in order to get the answer for this one? Let me give you a small hint. It starts with hypo, ends with tenuous. Yeah, find out the hypotenuse, people, that's all. So basically what you do is AF square is equal to what? F, let's take this as G, alright, let's take this G, FG square plus AG square. You can take whatever letter you want, it really doesn't matter. So AF square, what is FG square? What is this distance? This is 1, this is 2 points, so that's, sorry, that's 1.5 square. What is AG square? 1 and 2, so that's 2 square. So basically guys, 1.5 square is 2.25 and 2 square is nothing but 4. So what do you have? 6.25 is what you have. Now this is AF square. So how will you find out AF? So what is AF then? AF is equal to root of 6.25. If you find out the root, you'll get the answer is 2.5 kilometer. So that is the displacement between A and F. Simple, voila people, voila. So that would be the answer for this very first question. I hope you guys were able to give the right answer for this. If you did not, it's okay, this is how you do it. I hope in your exams at least don't get it wrong, right? So that is the answer guys, you'll get it as 2.5 kilometer where the AF square would be 6.25 kilometer and AF is 2.5 kilometer. So that's the magnitude of the displacement. So option number B would be the right answer. That's it. Moving on to the next topic, people. The next thing I'm going to talk about is measuring motion. See, generally, guys, we measure motion. No, the one quantity that is used to measure motion is nothing but speed, right? Speed is one of the most common, common quantity that is used to measure like how fast something is going or how slow something is going. We also have velocity and acceleration as well. So let's start with speed and then get on to velocity and acceleration. So what is speed? Speed is what distance covered by the body divided per unit time or divided by time taken is what is called as speed. So the formula is what speed is equal to distance by time. And the SI unit of speed is nothing but meter per second. You've already seen all of this. And this is a scalar quantity because you don't consider the direction. Distance is also a scalar quantity. Because of that reason, the whole quantity of speed itself is a scalar quantity. We don't care about the direction at all. Whereas velocity, on the other hand, is displacement by time, and displacement we know is a vector quantity. Because of that, velocity is also a vector quantity. That means you consider both direction as well as and the magnitude as well. Both of these are considered when you talk about velocity, right? So that is one thing you have to remember. So you have negative velocity and positive velocity as well. We'll talk about that later, so don't worry about it. So velocity is defined as the displacement per unit time or rate of change of displacement is what is called as velocity. And the formula is velocity is displacement per time, but displacement is represented as s divided by t is nothing but time, and velocity is represented as v, or initial velocity is u, or final velocity is v. So v is equal to s by t is nothing but the formula for this one. Right, another question. Let's try and solve this one. This is also a very simple question. Simple calculation, easy peasy question. Again, guys, I don't want anyone to Google it. I want you to do it yourself. Alright, the question is this. A train 100 meters long is moving with a velocity of 72 km per hour. Find the time it takes to cross the bridge, which is 2 km long. Options: 85 seconds, 120 seconds, 150 seconds, or 105 seconds. A train which is about 100 meters long. A train. So this is the platform, right? Sorry, this is the bridge. So there's a bridge, right? This is the bridge. And this bridge is about 2 kilometers long. This bridge is about 2 kilometers long. And the train itself is about 100 meters long. Sorry guys, I've been sick for the past couple of days, so that's why. Cough. Controlling it is very hard. So anyways, so you know that the speed of the train, the velocity of the train is given as 72 km per hour. 72 km per hour is what the velocity of the train is. Now find out what is the time taken for it to cross the bridge. Alright, so your options are, see, they're all given in seconds, whereas speed on the other hand is given as kilometer per hour. So first thing, convert that 70 km per hour to meter per second. So how do you do that? So velocity is given as 72 km per hour. How do you convert it to meter per second? 72 into 5 by 18. So 2918, 236, 2612, 9436, 5420. So 20 meter per second is the velocity now. Now that you found out the velocity, find out what is the distance. So distance is given as 2 kilometer and 100 meters. Because the whole train has to pass, right? So first the whole train has to pass the 2 km. Then the tail of the train also has to cross that 2 kilometer bridge. So obviously that distance also will get added up, right? So what will happen? 2 kilometers is what, 2000 meters. So 2000 plus 100. So that's 2100 meters. Now put it in the equation, guys. Velocity is equal to displacement, so we'll take it as s, right? Displacement by time. So displacement is 2100 divided by 20, 0 gets cancelled, to 10, 20 to 5, 10. So that's 105 seconds. 105 seconds is the right answer for this question. All those who got it right, absolutely spectacular. If you did not, this is how you solve this, guys. In fact, these kind of questions are asked in your UPSC also. In your UPSC and all that, if you've ever planned to write your IAS anytime in the future and all that, they will ask you all these kind of questions, but it'll be a little bit more complicated. Obviously, they're not going to ask you the same question. It'll be a little bit more complicated, but yes, these are the kind of questions that you can expect over there as well. So it's not just for your finals. That's what I'm trying to tell you. You will be doing these kind of things in the future as well. So if you're someone who's serious about all of that, UPSC and all that, this is definitely the kind of thing that you have to be prepared for. Alright. So next question, people. Sorry, before the next question, guys, let's get into another topic. The next thing I want to talk about is types of motion. So there are two types of motion, guys. You have uniform motion and non-uniform motion. Uniform motion is when a body is moving in a straight line and it's covering equal distance and in equal interval of time. So for example, let's say that in every 5 seconds, the distance covered by a car is 10 meters. Next 5 seconds, again, it's 10 meters. So that means that he's going at a constant speed. Alright, he's going at a constant speed. So that type of motion is what is called as uniform motion. Whereas non-uniform motion is when a body covers unequal distance in equal interval of time. For example, in the first 5 seconds he covers 10 meters. In the next 5 seconds he covers only 7 meters. In the next 5 seconds he covers 15 meters. So there's an unequal distance being covered in equal interval of time. That is what is called as non-uniform motion. And in the case of non-uniform motion, guys, you generally don't find the speed, you find the average speed. So what is the average speed? Is nothing but total distance covered divided by total time taken, which gives you the average speed of the body. That is, what was the speed throughout the entire journey, what was the average speed throughout the entire journey. That is calculated by total distance covered divided by total time taken. Whereas average velocity on the other hand is nothing but total displacement by total time taken. So in both the cases, you're taking out the complete value. So in the case of speed, total distance by total time taken. In the case of velocity, it's total displacement divided by total time taken. That gives you the average velocity. Yet another question is, go ahead and solve this one as well. The maximum speed of a train is 90 km per hour. It takes 10 hours to cover a distance of 500 km. Find the ratio of its average speed to maximum speed. Such an easy question. Average speed to maximum speed is the ratio that is what you're supposed to find out. Is it 5:9, 9:5, 4:5, or 5:4? Such an easy question, guys. So maximum speed, first of all, max speed is given as 90 km per hour. Sorry. Average speed is given as what? Average speed is given as total distance by total time taken. What is the total distance? 500. Total time taken is 10. So that's what? 50 km per hour. So what is the ratio of average speed to max speed? 50 divided by 90, which is what? 5:9. I could have done it directly, but I still wanted you guys to, I don't want you guys to get confused. That's why I did it one step at a time. You can do it in one step. That's what you can, you can just write the statement and put it in one step. That's all the answer is. But I don't want to get you guys to get confused. That's why I had to do the whole thing. But yes, guys, the answer is 5:9. Simple. Moving on to the next topic, people. The next thing I want to talk about is acceleration. So what is acceleration, first of all? Acceleration is nothing but the rate of change of velocity. The rate of change of velocity is what is called as acceleration. Now, what is velocity? We know that velocity is displacement by time. So rate of change of velocity is nothing but final velocity, or the change in velocity is nothing but final velocity minus initial velocity of the body divided by time taken. So if you remember, I told you this formula as well. A, which represents acceleration, is equal to V minus U by T, where V is the final velocity, U is the initial velocity, and T is nothing but the time taken. And the SI unit is meter per second square. Now, in the case of acceleration, guys, this is also a vector quantity, because you're talking about velocity over here, rate of change of velocity, and velocity we already know is a vector quantity. So because of that, acceleration is also a vector quantity itself. So we consider the direction as well. So when you say positive acceleration, that means that the initial velocity is less than the final velocity, or in other words, final velocity is greater than the initial velocity. That is when you say that the body is going in positive acceleration. When the final velocity is greater than the initial velocity, that's positive acceleration. Because again, it's a, like I just told you, it's a vector quantity. So we also have negative acceleration as well. So negative acceleration is when the acceleration of the body, the final velocity, is less than the initial velocity. When the final velocity is less than the initial velocity, that is what is called as negative acceleration. We also have one more concept called as deceleration. Deceleration is nothing but acceleration in the opposite direction. Like for example, when you brake, like you hit the brake, right? The force is applied in the opposite direction. But then the car continues to move in the same direction, right? It'll continue to move forward. So that type of acceleration is called as deceleration, because the acceleration is in the opposite direction. That is what is called as deceleration, right? So that is also one more concept that you have to understand. But again, we'll be solving some more problems on this. So that is what is deceleration. So let's go ahead and try and solve this question, guys. Now in this question, you cannot directly use the acceleration formula. You have to use the equation of motion to solve this question. Let me give you that hint, all right? So either of the three equations, you have to use it, but try and solve this again by yourself, not Google. Google Baba will be there for now, but I want you guys to do it. Here's the question. A bullet hits a sandbox with a velocity of 20 meter per second and penetrates it up to a distance of 6 centimeter. Find the deceleration of the bullet in the sandbox. Your options are 333.3 meter per second, 33.33 meter per second, 3333.3 meter per second, or 0. Okay, let's write on the given data first. So the bullet hits a sandbox with velocity. So initial velocity is 20 meter per second. What is the final velocity, guys? Remember, once the bullet hits the sandbox, it penetrates a certain distance and it stops. So final velocity of the bullet is 0. Alright. Now you know the distance also. Distance is given as 6 centimeter. Convert that to meters because everything else is given in meters. So convert this also to meters. So that will be what, 0.06 meters divided by 100 because 1 centimeter is equal to 1,000. 1 by 100 meters, or 1 meter is equal to 100 centimeters. So you'll get is 0.06 meters. Now find out the deceleration. So okay, we can directly because there is no time given, you cannot use the formula A is equal to U plus AT. Why? Because they have not A is equal to V minus U by T. Oh my god, V minus U by T, you cannot use it because there's no time given. So let's use the equation of motion, that is S is equal to, no, you can't use that also. So we'll use this one, third equation of motion. V square is equal to U square plus 2AS. V square is 0, U square is 20 square plus 2 into acceleration is what you're supposed to find out into 0.06. So that's 400 plus 2 into 0.06 is 0.12. So 0.12 into A. So this goes to the other side. So minus 400 is equal to 0.12 A. So A is equal to minus 400 divided by 0.12, which if you simplify, you get it as 3,333.3 meter per second square. And it'll be negative, alright? It'll be minus 3,333.3 meter per second. No, it should be square, guys. It will be square, alright? Not meter per second. It will be meter per second square. Because obviously you're finding the deceleration, right? It should be meter per second square. Unfortunately, they've not mentioned it, but no, that is the right answer. Only 3,333.3 meter per second square. Right, guys? Yes, I have a news for you guys. If you guys are enjoying the session so far, first of all, take a second, subscribe to the channel, hit that bell notification so you get notified of all the future sessions, and like the video as well. And if you want to have more such amazing sessions with some amazing teachers, just like what we have on the Vedantu YouTube channel, click on the link that is given in the description as well as in pinned comment section, and right away enroll into the Vedantu Pro subscription course. Let me tell you what are the advantages before you make a decision. First of all, guys, you have unlimited live session. There is no limit as to how many sessions you can take in a day. It's up to you guys. And all of those sessions will be fun filled. More importantly, you will have some amazing quiz questions that are asked in every single session of yours. And those quiz questions will be pertaining to that particular chapter or that particular topic that you were taught on that day. So that will help you to understand what are your weaknesses and what are your strengths. You'll truly understand how good you have understood the particular concept, how much have you absorbed from what the teacher has taught you. And more importantly, guys, this gives you an opportunity to compete with the world and see how much better you can be every single day, because in every session you'll have quizzes and you'll have leaderboards. You'll have some amazing questions in those quiz questions, which will definitely help you to test yourself in every single session. And yes, guys, all of these sessions are recorded because obviously it's live, so don't worry, you'll never lose any data. All of these sessions are recorded, and the recordings are such a way that even while you're watching the replay, you can take the quiz and check out the leaderboard while watching it as well. So how cool is that? How mind-blowing is that? Even while watching the replay, it's going to talk to you. It's going to ask you for the quiz questions. You have to answer the quiz questions, and you have to check out the leaderboards. All of that even while watching the session. And yes, people, you can download all the premium content, all the notes, handwritten notes, everything can be downloaded. So again, you never ever miss out on anything that is important. Everything that you need is right here, right now. And yes, guys, yes, I know that a lot of you guys have a lot of doubts right now, wondering how to get your doubts cleared. Don't worry about that. We've got you covered, people, because inside the session, you will not just have one teacher to help you clear your doubts. No. In fact, every single session has two teachers just for you guys to ensure that all of your doubts are cleared inside the class itself. So with the master teacher, you'll also have the class teacher to ensure that all of your doubts are cleared right there and then. And unlimited doubts, 50, 100 does not matter. All of your doubts will be cleared right here, right then. And yes, you have some amazing tests and assignments also. And those tests and assignments, trust me guys, are like, it's amazing. It's just super amazing. Those questions are taken from some amazing sources like your sample papers from your past year question papers. It's designed such a way that it will definitely help you in your boards and your final exams and every other exam that you guys are preparing for. You will be trained for your ISOs, IMOs, every single competitive exams, NSOs, KVPY will be giving you training for all of those, all those extracurricular activities as well. So 5,000 plus micro courses and crash courses again, which includes all of the things that I just told you for free. What do you have to do? You might be wondering what you have to do. So what you have to do is basically this, guys. Right now I'm probably thinking that you guys are watching the session. So open any of the sessions, go to your show more, go to the description, go to subscribe to Vedantu Pro right now, click on the link and basically open up the course. This will first tell you what grade, they'll ask you which grade do you belong to. Let's say you're in 10th grade, once you click on that, they'll ask you which board do you belong to, or let's say you're in 9th grade, click on that and click on CBSE, ICSE, let's say you're in CBSE. What you have to do is basically check out all the information that I just told you. Everything you can find it over here. You can find all the teachers that will be teaching you, all the amazing results that we achieved in our last years, that is your 10th standard, 12th standard, IIT results, everything you can check out over there. And yes, what you have to do is basically click on proceed to pay and enroll into the course. I know that it seems like a lot of money, but think about it guys, because we are providing you with an offer. If you use my coupon code AMEPRO, you get a flat 20% discount on the course. So that means that from 2,000 rupees, which is supposed to go until March 21st, from 2,000 rupees, the price, if you use the coupon code AMEPRO, you get a discount of 20%, which will drop the price down to 1,600 rupees, which means that you're getting an offer of 400 rupees, which you can save and use it to buy something else later. And think about it guys, in that duration until March 21st, you would have attended a lot of sessions, roughly about 100-200 sessions, during this period, obviously not 340 because there are only few more days left. But in this duration guys, that means that per day, per session, you are just paying about 4.7 rupees. If you go for 340 sessions, the more number of sessions you take, the lesser money you'll be paying per session. How cool is that, right? And yes, if you think about it, it's less than a packet of Lays that you pay 10 rupees for, right? For your own education. And yes, the coupon code is AMEPRO. The link is given in the description, like I just told you right now, and it's also given in the pinned comment section as well. So check it out and enroll into the course as soon as you possibly can. Right guys, with that said, let's get back to the topic. Let's understand about graphs right now, the graphical representations of motion. What is it? Yes, we have two graphs. One is the distance time graph and the other is the velocity time graph. So distance time graph is basically the graphical representation. It's a line graph which shows the distance on the y-axis and time on the x-axis. So basically guys, if you have a graph, if you plot these values and you find the slope of that graph, if you want to find the slope of that graph, that will give you the speed of the object. So if you find the slope, so you can find out the slope by using the formula y2 minus y1 divided by x2 minus x1. So if you find out the slope of this distance time graph, it will give you the speed of the object. Whatever is the speed, you'll be able to find out. Now if you have a graph, so this is a graph of a body which is going in uniform motion. So whichever 2 points you take, it will be the same because obviously it's uniform motion, the speed is going to be constant. But in the case of non-uniform motion, whatever 2 points you're going to take, whatever slope you find, no matter which point you take, it could be P and R, it could be Q and R, it could be Q and P, it does not matter. That will give you the average speed. So when you find out the slope, you'll find out the average speed. That is something that is a little different over here. So when you find out the slope over here, you'll be able to find the average speed. In this case, you'll be able to find the speed, because obviously the average speed and speed in the case of uniform motion is the same. So you don't have to worry about that at all. But here, it's going to be a little different. Now, the distance time graph, if it's parallel to the x-axis, if it's parallel to time axis, this means that the body is in the state of rest. This means it's in uniform motion. If it's a linear curve, if it is a curved, then if it is a curved plot, then it's basically non-uniform motion. So these are the things that you have to keep in mind when you talk about distance time graph. So I'm going to ask you a question based on the same people. Now, this is something that I have not talked about, but I'll tell you right after this one. The question is this: there are 4 cars A, B, C, and D, which are moving on a leveled road, right, on a straight, clean, newly furnished road. Their distance versus time graph is given below. Which statement of this is correct? So you see this A, B, C, and D. You can see that, right? So B, A, D, and C is how it is from bottom to top. So the options are: is car A faster than car number D? Is it that car B the slowest? Is it that car D is faster than car C? Or car C is the slowest? Go ahead and try to find out the answer for this one, guys. I'm giving you 5 seconds to read the question and then answer it. Pause the video if you need more time. And more importantly, guys, do not cheat. Do it for yourself. Don't do it for anyone else. Don't do it for the sake of doing it. Because anyways, without, YouTube is free. So don't utilize it. Utilize it and make the best out of it. Alright. So go ahead and answer this, guys, in 5, 4, 3, 2, and 1. If you ask me, guys, just think about it. For the first statement, is car A faster than car D? No, it is not. Why? Because, guys, the more steeper the curve, the faster the object. So if I have 2 graphs, one is over here and the other is here, this is faster than this one. So more the angle, more the steeper the curve, more the speed of that car, or more faster the object is. So in this case, obviously this is not true, because obviously D is much more faster than A, because D is more steeper than A. B, on the other hand, is definitely the slowest, because among the 4, this is the one which is the least steepest. So yes, this is definitely correct. What about the third statement then? Car D is faster than car C. Car D is not faster than car C. In fact, car C is much more faster than car D. And finally, car C is the fastest, not the slowest, and hence option number B would be the right answer for this question. That's it. Alright, guys, with that out of the way, let's talk about velocity time graph now. So velocity time graph is basically, guys, velocity on the y-axis and time on the x-axis. So again, over here, if it is a linear curve which is which is moving upwards, then it's positive acceleration. If it's parallel to the time axis or x-axis, then it's zero acceleration. In other words, it's uniform motion. Then if it's going down, because obviously rate of change of velocity is what is acceleration. So zero acceleration means the body's velocity is not changing. So that means that it's uniform velocity. And if it's going down, if it's coming down, then it's negative acceleration. So again, here, if you find out the slope of this graph will give you what is the axis. So if you take any 2 points and find out the slope, again, slope formula y2 minus y1 divided by x2 minus x1. So if you find out the slope, you'll get the acceleration in this case. In a velocity time graph, you'll find out the acceleration. And if you find out the distance under the curve, if you find out what is this distance under the curve, that will give you the displacement of the object. This is something that a lot of students get wrong, and do not ever forget this, guys. If it is like this, if you whatever distance, whatever is the area under the curve, that will give you the displacement. And obviously in this case, this is obviously non-uniform motion, because obviously what do I say? What do you call it? It's not exactly a straight line. If it's a straight line, then you can say that it's it's non-uniform motion. See, obviously in this case it's non-uniform motion itself, but here you see that the acceleration is sometimes it's positive acceleration, sometimes it's negative acceleration. But one thing you have to understand is this, guys, we have not talked about non-uniform motion with variable acceleration right now, because that you'll be studying in your higher grades, not right now. But you have to understand is that in all these cases we are talking about, if it is uniform motion in a velocity time graph, the graph would look like this. It's going to be parallel to the x-axis because the velocity is same. But if it's a linear curve, that means it's non-uniform motion with constant acceleration. So in all these cases, you see this is constant acceleration, this is constant deceleration. So So in both the cases, you see that it's non-uniform motion with constant acceleration itself. So that is what your velocity time graph gives you. So this is uniform motion or zero acceleration when it's parallel to the x-axis, and this is when you have non-uniform motion with variable acceleration, which is not exactly a straight line. You can see that it's a curve. But then this you'll be studying in your later grades, that is in your 11th and 12th. You'll be studying more about it. Right now, we're not going to focus much on it. We'll just touch up on it. That's all. This is what the graph would look like. It's not going to be a straight line. It's going to be a curve. If it's a curve, that means it's non-uniform motion with variable acceleration. But again, 11th and 12th is when you'll be studying that. And yes guys, like I told you, the area under the curve in this case will give you the displacement. So no matter what the graph looks like, if you find out the area under the curve, that will give you the displacement in the case of velocity time graph. Let's do another question based on the same people. The question is, find out what is the acceleration and displacement respectively for given graph from A to B. So the body is going from A to B, find out the acceleration as well as the displacement. So how do you find out the acceleration? Let me just do it over here. Acceleration is what you have to find out the slope. Acceleration is basically the slope of the curve. Slope is nothing but given as m. So m is equal to y2 minus y1 divided by x2 minus x1. So what is y2? So this is what 6 comma 12, and this is 1 comma 3. So this will be x2 comma y2. This will be x1 comma y1. So that is what it is, right? So what is y2? Y2 is nothing but 12. 12 minus 3 divided by x2 is 6. 6 minus 1. So that gives you what? 7, 8, 9. 9 by 5 is what you get. So if you simplify this, what do you get? 1.8, something around 1.8 meter per second square is what you get. So the acceleration is 1.8 meter per second square. Now to find out the displacements, how will you find out the displacement? You have to basically find out the area under the curve. So you have to find out what is this area. So how will you find out this area? Area of trapezium wala formula you have to use. So area of trapezium, it's a trapezium, right? This is basically a trapezium. So find out the area of trapezium. If you remember the formula, area of trapezium, trapezium is basically equal to half into the sum of two parallel sides, sum of parallel sides into the perpendicular distance between them, perpendicular distance between them. So what is the sum of two parallel sides? Half into the sum of two parallel sides is what? This is 3. Okay, let me just use a different color. So yeah, which color, which color do you choose? This is 3 plus, okay, I think that is a little too light. Let me go with blue. Alright, so this is 3 guys. And what is this distance? This is nothing but 12. So plus 12. And what is the perpendicular distance? Perpendicular distance is nothing but this. So what is the, that is 6 minus 1, which is nothing but 5. So simplify this, what do you get? So that is half into 15 plus 5. So 15 into 5 is how much? 5, 5, 25, 2, 5, 1, 75. So that's 75. 70, okay. Into, sorry, this is into, that's how I thought, yeah. So area is equal to what? Area is equal to half into 75. So if you simplify this guys, you'll get it as what? 326, sorry, yeah, 236, 236, 714.5. So 37.5 meters would be your displacement, if I'm not wrong. Yes, 1.8 meter per second square and 37.5 meters. That's it, people. Yeah, I'm happy now. I did not make any calculation mistakes. I'm happy about that. Awesome, guys. So that is the answer for this question. With that said, the second last topic for today, which is something about equation of motion, which is a very, very important topic because you know about it. It's a very important derivation. We cannot ignore this result. So let's try to do it quickly. Let's try to do this, guys. So yes, what I'm going to do is, first of all, I'm going to take a velocity time graph with non-uniform motion, obviously. With non-uniform motion with constant acceleration. So this is my graph. That is what it's going to look like. So initially the bodies are not, it's not like it is starting from 0. It has already moved a certain distance. Then the velocity starts to change. So it has already moved a certain distance, and then the velocity starts to change. So this is what the graph would look like. So you see this, guys. This distance, this is AB. I'm going to take this as U. This is nothing but U. All right. I'm going to use a different color so that you don't get confused. Whatever I'm going to write with yellow. All right. So this distance, this is the total, velocity, which is nothing but final velocity. This is the initial velocity. This is the final velocity. And what I'm going to do is, if this is u, then I can say that this is also u. I'm just gonna take it to the other side. So if because they are both parallel, AB is also parallel. AB is parallel to DE. I can say that whatever the distance of AB is, D is also same distance. So D is also nothing but u. Now, this is the total time taken, which is nothing but t. Now, what is the formula of acceleration? Acceleration is what? Final velocity minus initial velocity divided by time taken. Acceleration is a. Change in velocity is what? V minus u. So V minus u divided by t is what you're going to get. Now, I'm going to take t to the other side. I'll get it as 80. I'll get it as 80. So what is 80? 80 is equal to v minus u. Now, what is v, guys? From this equation, let me use a different color. From this equation, we know that v is what? V is CE. V is CE. And what is u? U is nothing but d. So I'm, in place of v and u, I'm going to replace it as CE minus d. Alright? Now, here's the magic. Listen carefully. We know that this distance, CD is what? CD is equal to CE minus D. That is what it is, right? CE minus D. What is CE minus D? We've already seen that as what? It is V minus U. And so if that is this, then what is CD then? CD will be 80 then, right? CD will be 80 because we have just found out that the equation of 80 is equal to CE minus D. What is CE minus D? CE minus D is nothing but CD. So what is CD then? It's 80. So in place of CE, I am going to substitute 80. That's your first equation of motion. That is 80 is equal to V minus U. Rearrange the equation. So V is equal to U plus 80 is your first equation of motion. That's it. Simple, guys. You just need to draw the graph and use acceleration wala formula. Substitute the value of CE in place of CE, put it as 80 and you'll get the answer. Next derivation, you're going to find out the displacement. How will you find out the displacement? Area under the curve. But this time I'm going to use not the area of trapezium wala formula. I'm going to use area, because see guys, a trapezium can be divided into basically a right angled triangle and a rectangle. So I'm gonna, when you add both of the areas, you'll again get the same answer. So first thing I'm going to do is I'm going to find out the area of the rectangle. So areas of rectangle is what? Length into breadth, and area of a triangle, of a right angle triangle, is half into base into height. So length is what? This is what is the length? AE into BA or CD, or we'll take it as CD itself. AE into D is nothing but your area of the rectangle. What is the area of the right angle triangle then? Half into base into height. Base is nothing but CD, this is the base, and height is nothing but BD. So BD into CD is nothing but the the base into height. Put it in the equation. So what is BD? BD is nothing but T, that is nothing but the time axis. CD is nothing but 80, and A is nothing but U, and D is nothing but T. So what do you get? UT. And here it's nothing but half into 80 square. Add both of them up. So this is nothing but displacement. Displacement is nothing but S. S is equal to area of ABDE plus BCD. So area of ABDE. I know it's a little boring, guys, but what to do? We have to do it. There's no other choice. That is, what is it? What is this distance? This is UT plus half 80 square. And this is your second equation of motion. That is S is equal to UT plus half 80 square. That's all. This is your second equation of motion. You just need to find out what is the displacement. Third equation of motion, I am going to use area of trapezium wala formula. That is half into, half into the sum of two parallel sides into the perpendicular distance between the two parallel sides. So basically, guys, I'm going to use that formula, and I'm going to get the same. This is the equation that I'm going to get. So I'll get it as C into AB into AE. So what is this? So CE is nothing but this distance into AB into this distance, that is nothing but AE. So that is what I'm going to get. Now what is AE? AE is nothing but T. What is AB? AB is nothing but U. What is CE? CE is nothing but V. So I'm going to substitute that values over here. Now what I'm going to do is, from the first equation of motion, that is V is equal to U plus 80, I am going to find out what is T value. So what is T? T is equal to V minus U divided by A. Just, rearranging the equation to get it. Now what I'm going to do is, I'm going to substitute this in place of T. So what will I get? S is equal to half into V plus U into V minus U divided by A. So I'm going to take this A to the other side. So I'm going to group it up. So 1 by 2 A into V minus U v plus u into v minus u is what I'm going to get. This is the first step. Alright, so basically do that. This is what you're going to get. Now simplify the equation. You will get it as what? If you rearrange the equation, take 2a to the other side, so you get it as 2a as v plus u into v minus u is nothing but v square minus u square multiplying. So it will be what? V into v and v minus u. So if you have to actually do it mathematically, so how will you do it? So v plus u into v minus u is equal to v into first, multiply this term with both the sides, both the other terms. So it will be v square plus or minus vu plus uv, this term with this one, this term with this one, minus u square. So this gets cancelled. So what are you left with? V square minus u square. So put that over there, rearrange the equation, you'll get as v square minus u square is equal to 2as, or v square is equal to u square plus 2as. This is your third equation of motion. That's it. That's what we will. I know, but yeah, again, these equations are applicable for motion with constant acceleration, guys. For variable acceleration, it will be a little different, but you'll be studying about that in your higher grade, so don't worry about that. Anyways, let's go ahead and solve this one as well. So a person is driving in a car in a straight line with an initial velocity 4 meter per second and acceleration of 0.2 meter per second square. After 2 minutes, he applies his brake and car stops after traveling 7 meters. Find out the acceleration during braking. Options: 56 meter per second square, minus 56 meter per second square, 128 meter per second square, or minus 128 meter per second square. Go ahead, guys. Try and solve this question all by yourself. I'll also try to help you guys out. So first of all, write down the given data. Initial velocity is given. Okay, that is initial velocity is given as 4 meter per second. The acceleration is given as 0.2 meter per second square. Time taken is given as 2 minutes, which is nothing but 2 minutes, which is nothing but what? 120 seconds, because everything is in meter per second. So I'm going to convert this also to seconds. So it will be 120 meter per second. Seconds. Okay. First of all, find out what is the final velocity before he's applying the brake. So he is traveling for 2 minutes with some velocity. He started with 4 meter per second. What is his final velocity? Find that out first. So how will you find out the final velocity? V is equal to u plus 80. I think I can use that formula. So u is nothing but 4 plus a is 0.2 into time taken is 120 seconds. So 4 plus 0.2 into 120 is how much? I think it'll be around 24 if I'm not wrong. So 24 plus 4 is nothing but 28. I'm not really sure if my calculation, if I go wrong in my calculation, I'm really sorry guys. So 28 meter per second is what you're gonna get. Now that you found out this, sorry about that construction. Anyways, now let's find out the acceleration. So this is the final velocity. Final velocity now you found out is 28 meter per second. So once he applies the brake, he travels for another 7 meters and then stops, right? So the initial velocity since when he is applying the brake, that is 28 meter per second, and the final velocity is now 0. So now use the equation. Which equation shall you use? Because you have to find out the acceleration. You don't know the time taken also, you know the distance. So I'm going to use the third equation of motion. V square is equal to u square plus 2as. So v square is equal to 0. U square is nothing but 28 square plus 2 into acceleration is what you're supposed to find out. Displacement is 7 meters. So that's 28 square into plus 14a is what you have. So what you have is basically minus 28 into 28 divided by 14 is equal to a. 2714 21248 7214. So that, what is it? 816 1 224 5. So minus 56 meter per second square will be the answer for this question, if I'm not wrong. Yes, it is correct, people. Finally. And today I'm informed. Today I'm getting all the calculations correct for some reason. I don't know what side of the bed I woke up in, but that's good. So anyways, minus 56 meter per second square would be the answer for this question. Right? Last concept, people. That's it. I know that I've eaten too much of your head today. Last concept, that is nothing but uniform circular motion. When a body is moving with constant speed in a circular path, that is what is called as uniform circular motion. And the formula to find out the speed in this case is V is equal to 2 pi r by t, where V is nothing but the speed of the object, 2 pi r is nothing but the circumference of the circle divided by time taken. Now one thing you have to understand is this, guys. In this case, the velocity is changing at every single point. Why is the velocity changing? Because the direction is changing. The speed might be constant, but the velocity is changing every single second. So there is acceleration also, all right? And that acceleration will be towards the center, So this is where the acceleration would be like, and the velocity, change in velocity, the direction of velocity will be that way. Acceleration on the other hand would be this way. It will be moving towards the center. So velocity is changing at every point because the direction is constantly changing. Acceleration will be towards the center, and this is what the diagram would look like. So last question, guys. Go ahead and solve this. Just let's call it a day. Here's the question. Sorry. A person is traveling on a circular ground with uniform circular motion. If the radius of the ground is 42 meters and he's running with a constant speed of 6 meters per second, find out what is the time taken for him to complete one full round around the ground. Options: 7 seconds, 11 seconds, 14 seconds, or 44 seconds. Let's go into this. Come on. Sorry. Okay, they've not given me space to. Sorry, guys. Irritation. All right. God, that's bad. Anyways, the radius is given as what? 42 meters. Speed is given as 6 meters per second. Find out what is the time taken, right? So V is equal to 2 pi r by t. 2 into 22 by 7. So first, let's find out the distance, alright? 42. 7 or 6. 42. 44 into 6. Now, time is equal to 2 pi r by t. Sorry, by v. 44 into 6 divided by. So we'll get as 44 seconds. So that is the answer, guys. 44 seconds is the answer for this question. So that's it, guys. That is all for today. That's it, guys. Thank you for joining. I'm really sorry for the last part because I'm not so well. I've been having throat irritations for a long time now, so it all caught up to me towards the end. But nonetheless, click on the description to enroll to the course. Coupon code is AVPro to avail the 20% discount. Don't forget to like, share, and subscribe. We put in a lot of effort, so one like the Banta people. Thank you for joining. Catch you guys in the next one. Take care of yourselves. Stay safe. This is Anoop signing off for the day. Have a great evening. Catch you guys soon. Bye bye, guys. Take care. All the best.